Hello there guys, today we are going to talk about how to create a simple snake game in almost any language. That means that I am not going to explain the actual code, only the algorithm and how it works and how to implement it in different languages. Our today's topic is the game called Snake that everyone knows and almost everyone has played at least once. On an old game console, on the computer, maybe somewhere on some website and so on. So what do you think when someone says the snake game? You probably think of some different field, maybe like a rectangle with some width and height. So we will remember those things for the future. And also we have a snake. When the game starts, the snake is only a few units long. So for example, let's say just one for the sake of simplicity. And we have a fruit or maybe a few fruits lying somewhere on the field of the game, and when the snake connects to the fruit, when it enters the point where the fruit lies, the snake eats the fruit and grows 1 unit bigger, and a new fruit spawns somewhere on the map. So today I want to talk about how to do that, to make it work basically on every computer, console, and maybe even some special devices such as Raspberry Pis with custom screens, Arduinos and things like that with OLED displays. So first of all, when people implement the game, they usually create a list of elements where every element of the list is some part of the snake. So we have the snake list. So it is made out of different entries. The first entry is of course the head. The second entry is piece 1 and 2 and so on. And to find out how to draw them, the head points to the first piece, then to the second, and so on until we reach the tail. So when it comes to drawing everything on the screen, each piece has its own x and y coordinate for everyone, and when it comes to drawing, we just fill the data. Example, we have some image for a piece of the snake. For the head, that's awful, I understand. For the tail, I tried to make it as rectangular as possible, but then I gave up. And different maybe images for other pieces of the snake. Maybe it has to bend somewhere, and so on. That's how basically people draw the snake. And every frame they clear the field and do everything from scratch. And when it comes to updating the snake, every frame or every game loop, depending on how you want to implement it, we basically have some sort of general direction of the snake's head. So for example, there are 4 possible directions the snake can go, and the game knows what was your last input, and the snake will move there. And so the coordinate of the snake's head will, so it's x1 and y1, x2 and y2. Oh, I wanted to write 1, I'm sorry. And so on. And when it updates, for example, x1, y1 changes to y1 plus 1, and then the second pair of coordinates is changed to the first, and so on. And so each later piece of the snake's body moves to the position of the previous piece, and so the snake moves. However, I have a much simpler solution, and while I still remember when the game wants to detect if the snake has bumped into itself, it checks the head and every component and every other piece of the snake, if you may say so. If they overlap, then it's basically game over. And I have a very simple solution for that. All you have to do is to create an array. That's all we are going to need. An array of vectors, and I don't mean like vectors with 3 different coordinates or something like that. In this example, a vector is just a number that shows the direction of some particular piece of snake. For example, let's say we have a head, right? We have a head of the snake, and let's say it moves up, so it changes position, and we have to remember that when it moved upwards. Then it moves to the right, and so on. Oh, and we have the rest of the body too. And also we have the tail, which is basically another object which has only its position and not anything else. And after some time, when the snake's head moves, it travels a path that we can represent with these arrows. So since the snake can only move in 4 directions, we need only 4 bits to show if a snake has done some weird movement, and to make everything even more simple, we need only 2 bits for those 4 directions. So we can cramp 4 pieces of the snake into 1 byte. What do I actually mean by that is that when the snake travels along this path that I drawn here, we have this tail that is located, for example, over here. It looks where the arrow from this point is pointing, to the right in this example, and it moves to the right, removing the arrow that was drawn here previously, and then it moves up, removing this, and so on until it catches up to the head. Of course, it will never catch up because the head is constantly moving somewhere, but you get the point. So everything we need for this is X and Y for the head, and X and Y for the tail, and maybe well, not maybe, but we have to use some variable to show where the player wants the snake to move, so some other variable named direction that indicates where the snake should move on the next frame. And we have a huge array of those arrows. Of course, you have to understand that the snake's field of the game is usually very small, so it's not a big deal to create such an array. It doesn't need to have 2 dimensions. You can rework this logic to work with 1-dimensional array, but you have to remember that, for example, the array starts at 0 here, goes to 7 here, and then when you move to the 8th element of the array, it will be the first element of the new row. But it depends, it drastically changes on how you implement it in code, but in theory it doesn't matter at all. So when you change the direction, each frame it checks if the direction is up, it moves the snake up, and then looks for, so we have the head here, let's draw a square, and we have a tail somewhere here, and on the next frame it moves them both in the direction. So it moves the square here and the tail here, and sets this element, this arrow where the tail was, to 0, so basically erases it, and then it moves somewhere else, for example over here, and moves the tail here and erases this one, and this is erased of course too, and so on, and everything in the middle where there is a direction, it will use some graphics to draw it. Why this idea? Oh, and of course if you want to check if the snake has bumped into itself, you just check this element of the array where the snake will point on the next frame, so you take direction into consideration, and if there already is an element in that array that isn't 0, for example, where 0 represents no arrow, then it means that it is game over for the player. What is good about this approach is that it can be applied to almost any computer or anything else that you want to display it. You don't even need a display for that. Generally everything works fine. Let's take a look at the C code for that I made. It's not perfect in any way. The channel is called From Beginners for Beginners anyway, but you can see that we have some icons array, which is basically the graphics for the game. So you can see that element 0 is the top left corner of the snake, so it's probably when the snake rotates from top to left, it draws that element. It's basically from the ASCII table of characters, and we have an array for the actual game. This array will be turned into a string and displayed on the screen. So I had to take different things into consideration. Those are the border that we need to draw, and the new line character that we need to add after every row. And so we have some code to draw everything, some logic to move the snake each frame, and then we draw the actual snake, and so on and so forth. And when we press something, we get the character that we pressed. Check it with different keyboards, and if it corresponds to some direction, we update it, and we draw the display, the snake display on the screen. Let's see how it actually looks. It has some other code that I made in other files, so we will have to wait a bit until different things load. Right now it's probably loading something again. So now we choose the AI we choose the difficulty and we type snake, and we are ready to go. So let's play the game for a bit, and as you can see, it works just fine, and the speed of the game can be changed, but it works for the recording pretty fine. As you can see, not the best, but it works. And a very good thing about this, as I've already said a million times, is that you can implement it pretty much anywhere. So let's give ourselves a little more points and bump into ourselves. So we do something like this. I failed to kill myself. Okay, so here we have the game over screen, the score, and so on. And let's see a video that I uploaded to my personal channel, where I made the snake game on Arduino. So as you can see, we have the snake that moves along the screen, and we can control the snake with arrows. Let's see where I failed miserably. But as you can see, when the snake touches the fruit, it grows bigger. So it means that the head is moving in the direction that you entered, but the tail doesn't move, and that's enough to update the game when you eat the fruit. You don't need any list management or things like that. So as you can see, I implemented warping around the screen to come back from the other side, and when you die you get a nice skull and a binary representation of your score. So let's talk about spawning a new fruit for a bit. It's actually very easy. You just so for example, we have some snake over here, and we want to place a fruit somewhere, and let's say we put it here by a random chance, and we can see that it is inside the snake, so it won't do. We just move it to the right or to the left or anywhere you want, position by position, row by row. So if there is snake here, we will move it to the next row and move it to the right until we have a free spot. And of course, if the snake is the size of the snake is the same as the size of the gaming field, that means that we have won the game. Very simple and very effective. Is this method the best? I think not, because it is very hard to draw animation of the snake if we want the snake to move, not to jump from position to position, and it's not the best way, because maybe you saw some glittering in the C version of the snake, where the screen flashed for a bit. That's because it is very difficult for the console to repaint itself so many times with a huge message that is the game field. It's not the best, but it works everywhere. It works perfectly, and you don't have to change that much when you jump to a new computer or anything like that. You just need to change the visual representation of the snake regardless of what you are using, and it will work just fine. So that's it for today. Hope you found something new for yourself. I wanted to say enjoyed the video, but it's probably very difficult to enjoy something like this. But hope you learned something new and it sparked a little bit of interest in you to create something new and fun. That's it.